So this is for lab 1, and then I'm demoing that all 16 lights turn on for the 16 switches based on the program. Alright, so we got switch 1, switch 2, switch 3, switch 4, switch 5, switch 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16. All 16 switches work. They all turn off as well. Bam, 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 bam. Based on what switch it corresponds correctly. In lab 1, I worked on the XDC file, and I did the testing as well on my board and demoed how the board worked as well. And in the XDC file, I just had to make sure that I matched up what he put in the program, which was the SW and LED. I just made sure that they were lowercases so that it matched up with his code that he put in Verilog. And then for testing, I just had to, after the synthesis, after he already put the simulation for the synthesis, I ran synthesis, and then I generate the blip stream, and I open up hardware manager, I connected it to my board, and then I just made sure my board was on and that I was able to connect, and that I ran it and made sure all switching.
I created a modular Verilog design that connects all 16 slide switches to the Nexus A7 board on the 16 onboard LEDs. The core logic is written in the file switch LED interface.b. In this file, I declare a 16-bit input called X, which represents the switches, and a 16-bit output Z, which connects to all the LEDs. Each line inside this module assigns one bit from the input X directly to the corresponding bit in the output Z. In the file switch LED interface top.b, I've wrapped the core module with top-level ports named SW and LED, which match the naming used in the XDC constraints file. Inside the top module, I instantiate the core logic module and connect the internal X and Z signals to SW and LED. I also use a switch LED.xdc file to map each switch and LED to the correct physical pins on the FPGA. Each SW of I and LED of I is matched to a specific package pin using setProperty commands. After writing the code, I ran the synthesis to compile the logic, followed by implementation to map it to FPGA. Finally, I generated the bit stream and programmed the board. And when testing, each switch correctly turned on its matching LED in real time.